Okay, welcome to SSLongcat Part Dux, or Do if you want to be French. And this is a little bit of a clarification and a slight technical modification. Actually, not slight at all. That ain't the point, is it? Okay. Look up there. This is your redesigned SSLongcat high-speed dirigible. Okay, and we're trying to make it more efficient. All right. Ooh, you see some interesting stuff, don't you? That's correct, you do. So let's begin really quick. All right. Up there, you'll see the top view of the SSLongcat. She's changed some. That's right. You've got a double delta wing, one to the left, one to the right. Technically, just two triangles, all right? Ah, no, it's not Illuminati. Get rid of it. Okay, hold on. At the front, of course, is your command center and your bridge. Now, the two wings there will be on the top side. They can either be retractable or not, depending on what you want to do with it. Okay? It depends on the weight, and we're going to find out if it's going to be too heavy. So, anyway, in the ship center line, you'll see those four representative circles. Those will actually be Fresnel direct heat or passive heat thermal networking lenses. Okay, we'll get to them in a little bit. It's down the center line because it matches this if you were to do a singular center line element. Okay. All right, now that's for heating, obviously not for cooling, not when you get to Fresnel lenses like this. All right, they're redesigned Fresnel lenses. Anyway, the center line of the Fresnel solar wings is the ship center line, which is coupled to air or electric heaters. This depends. There's more than one way that we're going to do this at one time. That's the point. Recombination in varying forms at the same time and space. Okay? So, to make it more efficient. And you can couple that to to some drive turbines, Tesla turbine drives. Okay, there's a reason for it. All right, now possibly it also might have steam application. Don't ask, we ain't there yet. Okay, now the ship will have a forward-facing forced air venturi for heating and compression. You can consider it a Bussard ram scoop. Okay, but without the Bussard part. Somebody will get that joke, or not. I don't know. This is YouTube. Anyway, so now we're looking at one side of the delta wing or the power generation wing because we're increasing the size of the back of the dirigible of Longcat. Since we're increasing the horizontal size, you're increasing the ability to generate power. And there's more than one way to generate power in the same amount of space. Okay, we realize that. As you can see, the squares represent normal solar panels. Okay? The circles represent modified Fresnels. All right, and the Fresnel lenses will be glass with superlatticed chromium oxide acting as dry lasers for either forced air thermal expansion or steam. Okay, so the Bussard ram scoop would force air. You know, your solar panels would power your electrical elements and everything else that you need internally to the dirigible. Correct? All right. It might also run an air compressor. And the air compressor will force outside air from the ram scoop coming in, dumping into the modified Fresnels. Okay. But we're going to slim down this design. And we're going to make it, I guess you'd say, forced thermal expansion convection networking. Okay. Which will be not passive, obviously. It'll be direct heat because you're looking at 3,000 degrees, if not more. Because remember, these are modified Fresnels that I've not ever seen. I'm the one that designed them, so you got a problem, right? Yes, you do, son. We don't know. All right, so it might not work worth a damn, or these Fresnels might work great. So anyway, at a guess, I'm going to say physically they will work better. How much the percentage of regular glass Fresnels or plastic, or plastic, but plastic can't take the thermal shock, so you're looking at probably really thin glass, layered glass. It's very I don't know how that's going to work. So anyway, especially if you got into carbon nanotech, that would begin to screw up the electromagnetic properties. It'd be interesting. Anyway, moving along. So those dump into a possible network, all right, thermal expansion network, heat or air, okay, compressed air. As it passes through, it gets super hot, gets passed back in to either the Tesla turbines, which act as a motive force, right, forced air, okay, all right, or it can go directly to your lift bladders. Secondly, if it was to be, how would you say it, variable, you could change from outside air and reroute helium, your helium element, or your helium gas, depending on the bladders that it uses. You might dedicate some of those Fresnels to just helium. So that way it would recirculate, that as the helium cooled in the bladder, it would automatically recirculate through the Fresnel network of dedicated lenses just for helium and pass it back in, keeping your lift always the same, right? Because this is technically a hot air balloon / dirigible, okay? All right. Now, at the same time, you can also do it, as I said, you can kill how much helium you have to use because it's expensive by taking the hot air balloon route and using just outside air or oxygen that's superheated to create buoyancy. All right, so those dedicated bladders, okay, can be fed by the same Fresnel network, okay, as forced air again, okay, all right, dedicated to oxygen. So remember that also, while I'm talking about this, the solar panels will be running dedicated either backup or primary heating elements and cooling elements. And I don't know why I said air conditioner last time. What I meant to say was refrigeration units that dump directly into each bladder, okay? All right, to cool it down and drop you. All right, so you understand? Okay, good. All right, so in this design, the delta wings are placed on top of the ship, doubling or tripling the thermally exposed surface to solar energy. It's real easy. The bigger, the better. As such, high heat Fresnels or Fresnels are modified that can be incorporated in the same thickness space alongside solar cells. However, they're not going to be able to coexist together because of the heat, the thermal expansion of the Fresnel network. Okay, which technically could be a square conduit of about 1/16 of an inch to an eighth. What do you think about that? I don't know, but you get the point. You want to make the conduit the same network size in thickness as your solar panels. Okay, do you understand? Okay, you understand. So, the solar cells are standard for powering onboard systems and centerline electric heating and cooling elements. I'm just saying centerline to make it easier. If you go with a centerline heating element, it would make life easier, and then feed each bladder from that passively. But we're going to fix part of that here in just a second, okay? Now, because you got to remember, all a centerline or all an electrical element is a rod that gets hot because you pass electricity through it. Didn't know if you knew that. So you can also add other ways at the same space and time to increase efficiency and decrease electrical power generation variables. Okay? All right. Okay. So the solar cells are standard for powering onboard systems, centerline electric heating and cooling elements, refrigeration, while also powering Tesla turbine drives on forced compressed air. Remember, some of the power generation from the solar panels will be set aside for a air compressor of some type or multiples. It just depends on the power requirements and the power you're able to generate. Okay? Okay. So, in this version, a forced air forward-facing Venturi Bussard ram scoop, somebody will get the joke, is added, and the Fresnel network will superheat the air or the internal helium, as I said before, to the gas lift tanks, or in the case of outside heated air, dumped into the Tesla turbine drives for motive force. Now, this is an interesting system because it doesn't have to be closed, but it can be closed, but you can also do it open when you're using the Fresnel network, because any incoming air will be, now incoming oxygen will be thermally induced, all right, and expand, go out the network, and you can either constantly replace the oxygen ends of it, acting as a hot air balloon, or not. Okay, if you want to just do closed recirculation, it's one of the, you can do either one. You can do both at the same time. It doesn't matter. Okay, but it would be easier for cooling the air bladders, the normal air bladders, non-helium, if it was an open system. You would close the system and let your Fresnel lenses do the work on the hot air balloon aspect of it. And when you wanted to cool, you would vent. Okay, you would vent and force cold air into the bladders. All right. Now, the hope of this is that the Fresnel lenses, and they do get hot enough. Okay, just stick with me. The hope of it is that the Fresnel lenses are adaptable enough that if you don't have any cloud cover and you're really jetting along with the trade winds, that these, depending on the size, 2 foot by 2 foot is easily 3,000 degrees. Okay, so these are modified beyond that, so you're hoping you can move a lot of hot air quick. Okay, all right. That being said, it would make it a lot easier if you could cool and heat fast as possible. That's the job. That's what you want done. All right, moving along. However, let me back up. Also remember that you can take your air compressors. Let's say you've got your buoyancy lift and everything's going great, man. You don't need any more hot air. You've got 10 minutes or so to go before you start to lose enough temperature that you start to drop. You can run that 10 minutes by building up enough compressed air using the solar panels to power an air compressor for the Fresnel lenses to heat that air and dump it back into the Tesla turbines. You understand? Compressed air dumps into the Fresnel network, superheated, passed into the, well, it's under compression at that point, more compression, MOAR compression, then dumped into the Tesla turbines for motive force. Okay, you can also have strict set to the side air compression tanks for that, because you're switching the network to doing what you need it to do when you need it to do it. Recombinated tech, fractalization in the same time and space of as many physical variables and constants as possible. So, moving along. The design does not account for water accumulation, which will occur at high altitudes. And in fact, if enough water is present when you thermally expand this with the Fresnel network, it'll act as a flash steam generator. If you're pulling in outside air and it's extremely cold and you hit that bastard with 3,000 degrees, you're going to start making, especially in a fairly wide area Fresnel network that's thin in thickness, you'll begin to detonate, and get you some flash steam. Okay, which is interesting and can be used for both power generation. Because remember, we're not even talking about, let's say you don't need your Tesla turbines to run and you don't need it to recirculate air for your bladders, your lift bladders, then you can suck in air and force it into an air motor for power generation to help your solar panels. You understand? Use the coconut. All right, so if it acts as a flash steam generator, you can dump that into the Tesla turbines, not a big deal, or any onboard steam generators. As I said, the delta wings may be retractable in sail form or rigid, depending on the weight requirements. And in this case, it's probably going to be rigid. All right. Now, on the center line of the ship, which I showed you above, where both wings meet, it is possible to add dedicated Fresnels of a much larger size directly to heat internal centerline element. So you've got your centerline element that feeds the other elements, or feeds the other lift bags. All right, yeah, because you're looking at a lot of different things going on at once. So let's say your centerline element's doing that. We'll just call it a rod. Your heating rod is down the centerline of the ship. Okay. At the same time, right in between both panels on the centerline, you can add really big modified Fresnels to superheat that element with less electrical usage. Okay. Okay. So, or in another form, you can also do it passively if you need to. Let's say you can't reach the centerline heating element, or you're using more than one element. Well, what you would do is expose part of those elements in whatever part of network that they have, linear, you get the point. You would expose some of those to the centerline of the ship, so the Fresnels that are hard attached there can do the work. Okay? So, there you have it, kids. That would be about the most advanced that I can get, short of anti-gravity, and the SSLongcat ain't getting fucking anti-gravity. Okay? I don't know nothing about no anti-gravity, and I don't know of any aliens that are going to stop by to give me none of it. So, there you go. Have fun, kids.